Hi everyone. We have the remainder theorem and the factor theorem we want to get through on this video. And the remainder theorem, I have it written down here and you can write it on your notes. The remainder, when you divide the polynomial f of x, some polynomial, by x minus a, is the constant f of a. And we'll deal with how you find that. So f of x is equal to the quotient of x times x minus a plus f of a. This is kind of a restatement of the remainder theorem. F of x is your dividend. It's what you're dividing. Q of x is your quotient. X minus a is your divisor. And f of a is your remainder. Alright, well let's put that into practice here with a couple of examples. Example 1 says, if f of x equals 3x to the fourth plus 2x to the third minus 5x squared plus x minus 2, find f of negative 2. So basically what we're saying here, notice I have negative a here, positive a here. I have negative 2. If x plus 2 is the divisor, now what I want you to remember is synthetic division. We won't do long division. Synthetic division. And we're going to use that to find f of negative 2. Now negative 2, which is the actual number, would go in the box because x plus 2 is the quotient that we're looking for. The remainder will be f of a, so f of negative 2. So let's put the negative 2 out here. Let's put the coefficients 3x to the fourth, positive 2x to the third, negative 5x squared, positive 1x to the first, and negative 2. Alright, and then we bring down the first number. Negative 2 times 3 is negative 6. 2 times negative 6 is negative 4. Negative 2 times negative 4 is positive 8. Negative 5 plus 8 is 3. Negative 2 times 3 is negative 6. 1 and negative 6 make negative 5. Negative 2 times negative 5 is positive 10. Negative 2 plus 10 is 8. Alright, so f of negative 2 will equal that remainder, 8. Now that's using synthetic division to find the function of the value of a function at a particular place. Now, the old-fashioned way, when you were dealing with function notations, maybe in Algebra I, would have us take 3, and then we put negative 2 in for x in all the places. 2, negative 2 to the third, minus 5 times negative 2 to the second, plus negative 2 minus 2. Everywhere where there's an x, I put a negative 2. Now if we evaluate that, negative 2 to the fourth is positive 16. Negative 2 to the third is negative 8. Negative 2 to the second is 4. Negative 2 is negative 2, and then minus 2. So let's multiply. 48 plus negative 16 plus negative 20 plus negative 2 minus 2, or plus negative 2 again. Since I'm doing that, I may as well be consistent. 48 minus 16 is 32. 32 minus 20 is 12. 12 minus 2 is 10. 10 minus 2 is 8. And you see how this remainder is consistent with the old function notation. But we can just use synthetic, I said division, let me change that to synthetic substitution. We can use synthetic substitution to find the value of a function at a particular value. Just put that value in the box, don't change it to its opposite, put that value in the box and do what we did when we were doing, that was a good alternative to long division if you recall. Alright, the next part is the factor theorem. Let me get all situated here. Factor theorem says the binomial x minus a is a factor of the polynomial f of x if and only if f of a equals 0. Okay, it's a factor. It means it goes into it evenly. Remember, f of a is the remainder. If the remainder is 0, x minus a is a factor. So we want to show that x plus 5 is a factor of x to the third plus 2x squared minus 13x plus 10. Well, this time I'm going to put negative 5 in the box because f of negative 5 would be 0. Notice how that's negative a there and positive a there, so that's always got to change. So I want to put 1 x to the third, 2x to the second, negative 13x to the first, and positive 10 as my constant. Bring down the 1. Negative 5 times 1 is negative 5. 2 plus negative 5 is negative 3. Multiply. Negative 5 times negative 3 is positive 15. Negative 13 plus 15 is 2. Negative 5 times 2 is negative 10. 10 and negative 10 is 0. It is 0, by golly, so it is a factor. X minus 5 is a factor. So what we've shown also is x minus 5 times, remember if this is third power, we drop down 1, x squared minus 3x plus 2 is equal to x to the third plus 2x squared minus 13x plus 10. Now this is a factor, but I want to make sure that I can write it in its, that I can factor this part too. So x squared, let's see, let's multiply and see if we can get something that equals 2, and let's add and see if we can get something that equals negative 3. And negative 2 times negative 1 does equal 2 and does add up to negative 3, so that works. So I had the x minus 5 already. We had to show, sorry, not x minus 5. Go back and change that to x plus 5. Had the x plus 5 out here already. Now, from our other part, from factoring this part, that's x minus 2 and x minus 1. So x plus 5 times x minus 2 times x minus 1 is equal to x to the third plus 2x squared minus 13x plus 10. We use the theorem by showing the remainder is 0, but what's left is also a factor that we can also factor even more. So I want to make sure you do that. Okay, let's look at one more example. It's the same thing as example 2. The instructions are the same. Show that x minus 1 is a factor of x to the fourth plus x to the third minus 11x squared minus 9x plus 18. Then find the rest of the factors. Period. Alright, let's put 1 here in the box. Put 1, 1x to the fourth plus 1x to the third minus 11x squared minus 9x plus 18. We'll put that there and do the long division here. 1 times 1 is 1, 1 plus 1 is 2, 1 times 2 is 2, negative 11 plus 2 is negative 9, 1 times negative 9 is negative 9, negative 9 plus negative 9 is negative 18, negative 18 times 1 is negative 18, and that is 0, so yes, x minus 1 is a factor. Now, this is fourth power, so this starts 1 down. So I do have the x minus 1 as a factor. I have x to the third plus 2x squared minus 9x minus 18 as another factor. Now, this may have more, and what I want to do is just check. And I want to check if we can find the zeros of that. We also are finding maybe the factors. So I'm going to put the y equals, I'm going to clear this equation, I'm going to put x to the third plus 2x squared minus 9x minus 18. I'm going to graph that. Now I want to know where that equals 0, so that's why I'm graphing that. Let's just take a look at the graph and see if there's something that shows up. And if I can just find one of them, and I'll maybe even deal with this positive. 1, 2, 3. I wonder if 3 is a 0 of that. So what I could do is we could use the calc function for zeros, and we could use the -2. Maybe this is -3. I'm going to go for the +3 right now. Any one of those is, whoops, past it. There we go. There's one point. There's another point. I was below the line, now I was above the line. Guess, yes, let's guess. Yes, 3 is a 0. So, I'm going to say that 3 would give us 0, just like 1 did. And into the rest of this, 1, 2, -9, -18. I bring down the 1. 3 times 1 is 3. 2 plus 3 is 5. 3 times 5 is 15. -9 plus 5 is 6. 3 times 6 is 18. -18 plus 18 is 0. It works. So now I got x minus 1. And this is x minus 3. And this is, it was third power, is what I put up here. X squared plus 5x plus 6. And I think I can factor that one too. And this will be 2 times 3 is 6. 2 plus 3 is 5. So I'm going to go x plus 2 and x plus 3. So I got them all. All right, we'll try that for now.